Hi, we're talking about the quotient rule. Be careful because sometimes you might feel tricked by the quotient rule, but you do have the skills, you will be able to do it, so don't worry about it. So first off, we've already briefly talked about the quotient rule, but let me just remind you, we have something like y to the power of 6 over y to the power of 2, because the base is the same, that big font number, that y, then we're allowed to just do 6 minus 2 is y to the power of 4. Well, what if we have some coefficients in front of that? What if we have like 12 y to the power of, I don't know, 5 over 4y? Okay, well now we need to split this into two different problems. We have our fraction or our coefficient in front, and we have our exponents second. So first let's look at our fraction. What is 12 divided by 4? Well, it's just the number 3. Cool. Now we can look at our exponents. Y to the 5th divided by y. What's the invisible exponent? It's a 1. So we can use our trick. 5 minus 1 is 4, y to the 4th. Well, what if we have a coefficient that doesn't divide beautifully like that? Like what if instead we have 14z to the power of 8 over let's see, how about like 12z to the power of 3? Okay, again, we're just going to split that up into two parts. But this fraction, 14 over 12, it doesn't divide to like the number 3 or the number 5 or something. So we're just going to simplify this. We're going to simplify 14 over 12. They're both even numbers, so they simplify to 7 over 6. Now we can do our z, or our exponent, z to the power of 8 divided by z to the power of 3. Because they have the same base, we're allowed to just do 8 minus 3 is 5, so we have z to the power of 5. Notice how, yes, it's a fraction, but we wrote it exactly the same as this whole number coefficient, where we could even put this invisible multiplication symbol if we want to. Coefficient in front, and the base with the exponent after it. Then the last thing I don't want you to get tricked by is what if you have more than one letter? What if we have like x to the power of 3, y to the power of 5, z, over x, y to the power of 3? Well, just like we did before, we're going to break it up into parts. We're going to break up the x's, we're going to break up those y's. So let's do the x's first. We have an invisible exponent, and it's a 1, so 3 minus 1 is 2, x to the power of 2. Now let's do the y's. Oh, look at that, it's going to be a 2 again. 5 minus 3, they have the same base, they both have a y, so 5 minus 3 is 2, y to the power of 2. Well, what about this z? It has nothing on the bottom. That just means there's nothing that's going to divide it out or cancel it out, so it's just chilling over there with a z. So both of these different types of ways you could be tricked, really you're just splitting the problem up into multiple steps. You got this.